if the engineer is looking for error events in the file traces. In the past, he was scanning through the file where he was looking for certain thresholds to be turned down or certain events occurring on different sensors. By having such a solution, or by having these data in a big data solution, these scans can be done automatically. This means you can have a web page with a graphical display, a dashboard, where these events are already published and the engineer does not have to search for it. They just click on it and are able to analyze it. And they also know when it took place, in which device it took place, and how the circumstances were. And as even an additional benefit, you are able to pull in additional metadata about how was the weather, was a driving condition, for example, wet, was the sun shining, and so on. Something that wasn't possible if you look at a certain trace file.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts, and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth-Hader. In today's episode of We Talk IoT, we dive into the world of R&D, where traditional methods of analyzing heaps of data quickly become obsolete. My guest today is Alexander Wechsler, a cloud solution architect and CEO of Wechsler Consulting. We will talk about the shift from manual file-based data analysis to the seamless cloud solutions of big data analytics. Envision automated reports, AI-driven insights, and rapid feedback loops that dramatically speed up time to market. It's great to have you on the show, Alexander. Welcome. Why don't you tell our listeners who you are and what it is you do?
Thanks very much, Ruth. Yeah, Alexander Wechsler. I do have quite a strong background in Windows embedded as well as backend systems. And over the last years, I moved a lot into architecting cloud solutions for embedded solutions, which now have to shift from on-premises situations into the cloud. And that's very much where we focus on currently.
And why do they have to move?
Because of different reasons. One side is a cost aspect. If you have solutions which gather a lot of data, where you have a lot of log files, trace files collected on premises, this means a lot of storage devices you have to take care of. You have all the maintenance and you have to build up that complete infrastructure yourself, which means leveraging cloud benefits such as on-demand access to storage, having platform services which scale elastically is bringing a huge benefit to these types of solutions.
And despite the cost and the data handling, what other benefits are there for organizations to think about moving to a cloud platform?
One of the great enablers, if you want to go to a cloud solution, is to break up the file boundary. Because nowadays, in classic analytic solutions, most people are working with file-based approaches. If you move to the cloud and you store the data you gather in not only on storage, on file systems, but in big data solutions, meaning clusters, query engines, and so on. By doing this, you're breaking up the file boundary. And this is a huge enabler because you're now able to see the complete set of data without being limited to the single file.
And why is this particularly relevant for R&D departments? That's, I think, what you focus on, correct?
Yeah, because in a classical scenario, you do something with your device. And you take a log file, a trace file, and then the engineer sits down after he received the trace file, and he is scanning the file for certain events, for errors, for important thresholds, and so on. And he has to do this over and over again for any trace file which comes in from the test team, so to say. If you are able to pull all the data you have into a cloud solution, into a big data solution, then you are able to automatically detect these types of events without the engineer having to do this. And the engineer can start right away working on the specific events he was looking for. And that's a huge win, looking at work time and also tedious effort to scan through those types of files.
And how does this work in a day-to-day area? I would think, for example, companies that do have a lot of log files and trace files and collect a lot of data in their test environment would be probably in the automotive industry. Could you give like a day in the life example? What changes now for the test engineer? Like how do you have to train the system to help you sift through these heaps of data?
I think the first step is to rethink your application or the way you're working with log files. If you do just lift and shift and bring the data into the cloud, this will not be helpful. You need to think, how is the data you collect nowadays transferred into big data analytic systems to be queryable and to be more easily accessible. And if you're able to do this, the day-to-day work changes dramatically because no one has to sit down and look into a file system to open files. But they, for example, could just start right away looking at the dashboards, seeing, okay, we had this car, this truck, this bus, and we drove around a certain circuit or a certain route on the map, and we had these error events. We had this different types of other events, and they are able to jump into their work right away without having to do a lot of file handling, additional administrative work they normally would have to do.
And you mentioned something called the lift and shift approach. Why is this so problematic? And what is it?
Lift and shift means taking the on-premise solution architecture as it is and just copy it over into the cloud. And this is very problematic because you're not creating any additional benefit. You're just having the same as on-premise in the cloud, and you're not really targeting the cloud benefits such as on-demand compute, on-demand storage, or also the elastic scale capabilities when you're using such an approach. And very often that's also more cost intense as if you would rethink that approach and go for a cloud native solution.
Okay. So basically it's like any moving, like whether you move house or whether you move your in-house solution to a cloud, like a technical system, you have to clean up and throw away the stuff you don't need first, and then it's easier to move, correct?
Yeah, and put the furniture differently somehow to make it fit better.
Yeah, and maybe you don't need 50 pillows, you just need the 2, or just as an example, right? Okay. So, this is something where then you as a cloud solution architect help the clients, like to prepare the data and consult on how.
Yes, exactly. It's always the question, how do you ingest the data into the cloud? Also rethink, good example you made just with the pillows. Do I need my 50 pillows or would 2 be enough? So do I need all the data? Is all the data still relevant? Because normally test engineers, of course, say, I need everything. But in real life, you may just need 10%. And by having just 10%, you're much faster querying and processing the data, of course. Yeah, normally, if you start such a new architecture for such a solution, you start with the ingress, think about how is the data uploaded into the cloud? Does it need to be processed? Does it need to be extracted? What are data schemas in the databases and so on? But there's a lot of detailed work. Once you go through this process, you enable all the benefits coming with the cloud because you're able to leverage platform services and platform analytics engines, which help you to be much faster and much more productive with the type of data.
Yeah, that makes a lot of sense. What other challenges do organizations face when considering moving to the cloud? First, you have to get your house in order and clean up your data. And what other challenges do you have?
Yeah, one big challenge always is to get the engineers used to the new approach because they said, oh, no, we need our file-based tools because we always have been using them. But if you move to that new type of solution, they don't have these types of tools anymore because these are also file-based, and that's just the boundary you want to tear down. So there is a small learning curve, I would say, always part of this journey, but it's only a small one, because as soon as the engineers detect that, oh yeah, I see all the events I need in the first dashboard, I can click on them. And even if I still require the file, I could download it because you don't have to throw away everything. Then they get very quickly accustomed to this approach and don't want to miss it again. That's the experience we have made.
Yeah, I imagine it's always a question about change and adoption and how you present the use cases that then the engineer finds useful or can relate to and say, okay, this is exactly what would help me, what I haven't even been looking for. What would be a killer argument to convince an engineer that the cloud is the right solution for him?
I think productivity. We always tend to take the approach not to take away everything from them and say, oh no, you have to switch completely. Quite often in the migration scenario, you have still a time where both solutions run in parallel. So you can say, try, test it out. You can work with files or you can work with a new system. And we have found out that after the first few weeks, that even older engineers, which have been working 20 years with files and tools, get accustomed to the speed they gain in the cloud and the productivity increase. There's also innovative ideas come with a new approach because they see, okay, I have new possibilities and things that were very hard to do before are now easy. So I can do this and that to be, faster, to be quicker, to have a much better quality in my data approach than I had before.
It's always the easiest when you find a use case for people and when the engineer then actually realizes that now he has more time to do something else. I think that's probably the most important part of any adoption or digitalization project that has come up in this podcast quite some time, that it's also sometimes a culture change even is needed, that the productivity gains are not seen, but the culture and the way of working they have been doing, it's just hard to change.
Yeah, that's a good description. It's a culture change. Absolutely.
Yeah. We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by Avnet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com. You mentioned something like dashboards and big data and analytics. So how does this help shorten time to market cycles if I can use these solutions?
For example, if the engineer is looking for error events in the file traces, in the past he was scanning through the file where he was looking for certain thresholds to be teared down or certain events occurring on different sensors. By having such a solution, or by having these data in a big data solution, these scans can be done automatically. This means you can have a web page with a graphical display, a dashboard, where these events are already published and the engineer does not have to search for it. They just click on it and are able to analyze it. And they also know when it took place, in which device it took place, and how the circumstances were. And as even an additional benefit, you are able to pull in additional metadata about how was the weather, was it driving condition, for example, wet, was the sun shining, and so on. Something that wasn't possible if you look at a certain trace file before.
Yeah, there's probably also data that has not even been collected before, right?
Well, maybe it depends on the device. Some devices collect temperatures as well, but of course they may not be available on weather conditions, on wind conditions, and so on. which may also falsify normal test results.
Mm-hmm. And what role does machine learning and artificial intelligence play, in your opinion?
That's the next evolutionary step, of course,
Okay. Mm.
Because if we have all the data in one big pot, we're able to do pattern detection. That's where artificial intelligence comes in. That's one of the simple use cases, so to say. But you also could analyze trends much more easily. Again, if you're not file-based, you can do the trends analysis not only on a test-to-test basis, but over a month or a year, depending on the test device you're having. And with a growing number of tests in your database, you're able to create digital feedback loops. You can see, okay, I have these types of errors on this device. I take these actions. Do they get better? And this can also be trained in a model, for example, so that the model could create a kind of self-tuning approach to get rid of specific errors.
Oh, that'd be helpful.
That's really the next evolutionary step. We're not there with everything, but we're trying to get there. Yeah.
Yeah. So that's something to watch out for in the next 5 to 10 years, or that's something that's already slowly starting?
It has started,
Okay.
and we're working on those types of digital feedback loops to get better and better. Of course, you have to find the right settings, the right configurations, the parameters, the algorithms. Some work, some don't. So that's try and error to a certain extent.
Can you share an example of a success story that you have implemented? You don't have to mention any client names, I understand, but is there something you could share?
We're currently speeding up the trace file processing for a large automotive customer, where we get down the turnaround to look at a certain trace file from weeks, months to days, because quite often those vehicles have been driving around somewhere. They take the traces, but then go back to the factory and upload the traces there. We're now directly uploading traces from where they're driving. So this speeds up the time engineers can look at those trace files enormously.
I think that is, for example, relevant for software updates within a car. And I've heard from some suppliers even that a short software update or a little upgrade or a patch even could take up to 1.5 years.
Well, yeah, it's finding the traces and the errors. Of course, you need some additional time to do the software updates and test those before they get released. But it shows the direction where the industry is heading to. And we're still in the beginnings because we're still collecting or we're still sending traces, and sometime later the engineers look at it. What could be the next step is that it's a real-time situation where the test driver is driving and the test engineer is sitting in front of his PC and he sees what's going on, and he gets a real-time experience what's going on, and he may be able to react to that in real time.
That'd be really cool.
In some scenarios, because if you do a longer drive, it might be too tedious for the test engineer to sit.
To watch the numbers roll in
front of the PC, yeah,
sure. So automotive seems to be really well suited for this kind of solution. Are there any specific industries that are not so well suited for this, or what other industries would benefit a lot from cloud migration?
I think it's not really limited to automotive. It's pretty much as the same for every company in the manufacturing industry, because they do test their products, they collect data, they want to analyze their data. So I'm not aware that there's a use case that would forbid such things to do. Yeah, and even in other areas like healthcare, for example, it may not be machine data then, but it may be health data, which could be collected, of course, using data privacy and everything, but having a broader basis of medical data to do better analysis, to detect patterns, for example, is always very interesting for doctors, for example, if they want to do a certain diagnose or want to get more assurance if their way of treatment is the correct one.
Is there a common myth or common misconceptions that companies have about cloud migration?
I'm not sure if there's a misconception. Some still shy away because it's work, and if your business is running and you say, "Hey, it's still working, so why should I change?" That's a great danger because the only constant is a change, and you will need to change at a certain time. And of course, your competition might be faster than you. So I'm pretty sure that going to cloud solutions isn't questions anymore, because no company, not even large companies, are able to set up the variety of different services and are able to maintain them from a cost perspective. So the cloud benefits are there. However, they need to be used wisely. And you need to know how to architect such a solution in a way that the real benefits come through and you not get entangled into the wealth of other services which might also be interesting but are too costly from a business perspective.
So what would be your advice to a company or to a CTO or an engineer that is still skeptical, or an organization saying, "Oh, this has been very interesting. How do I get started? What do I do?"
As we said at the beginning, don't do lift and shift. Try to rethink a certain solution or an aspect of your overall solutions and try to start simple. What quite often is neglected is that cloud enables you to do very simple approaches with a real good scale and high availability. So I see a lot of companies also jumping on cloud solutions, doing complex cluster architectures and so on. This is dangerous. But if you say, "Hey, I need a database, I need some functions to do an ingress, I need some analysis tools to get insights into my data," and do a very simple setup, that's a good approach to get successful.
Mm-hmm. What if somebody says, "Well, cloud computing, isn't that just the place where I store my data? Why can't I have this run on my own servers?"
Well, you can do this, but cloud could be much faster, more scalable, more available, and cheaper than your on-premises approach.
Fantastic. Alexander, it has been really great chatting with you, and thank you for taking our heads into the clouds. It has been really valuable. I hope you have a great day. Thanks for joining us.
Thanks very much. It was a pleasure.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.